Alright, so in the previous section we discussed trigonometric functions using unit circle approach. Now we will do using right triangles. Okay, so let's get started. The objectives are evaluate trigonometric functions of acute angle. So acute means degree less than 90. Yeah? Use fundamental trigonometric identities. Use trigonometric functions to model and solve real-life problems. Okay, so what are the trigonometric functions, right? Well, we have 6, but how do we define it using the triangle? Okay, well, when we mean a triangle, we mean a right triangle in this setting, right? So here, let's say that we have a right triangle and I have an angle theta. So the side of the triangle, that's where the right angle, so 90 degree is looking, it's called hypotenuse, right? Hypotenusa. And the one that's opposite to theta, that's called side opposite theta. And then we have this adjacent. Okay, so in short, here we call it op, if you like. Here we call it ADJ. With this, we can define the 6 trigonometric functions. So, sine of theta is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. Tangent is opposite divided by adjacent. The cosecant is hypotenuse divided by the opposite. The secant is hypotenuse divided by adjacent, and the cotangent is adjacent divided by the opposite. Alright? So these are how we define 6 different trigonometric functions. If you remember in the previous section, we looked at the unit circle, and then these 6 functions were defined using x, y coordinates, right? Okay. An example, to compute values for trigonometric functions given the angle and the triangle. So here we have a theta. We don't know what theta exactly is, but we're given the opposite side 4, adjacent side 3, and we don't know hypotenuse, but we know the Pythagorean theorem, so we can come up with the hypotenuse, right? Okay. So what is the hypotenuse? Let's call it x. So we know that x squared is equal to 3 squared plus 4 squared, which is 9 plus 16 is 25. So which means x is plus minus 5, but x is the side length. Length cannot be negative, so we call it. So it must be 5, right? So this is 5. Okay. Now, what is sine of theta? Sine of theta is opposite divided by hypotenuse, so it's 4 by 5. Cosine of theta is 3 by 5. Tangent theta is opposite divided by adjacent, so 4 by 3. Cotangent theta is 3 over 4. Cosecant theta, so cosecant theta is sort of opposite of the sine, right? It's the inverse of 1 over sine, if you like. So it's like 1 over sine theta, or if you like, it's hypotenuse divided by 4, the opposite, so it's 5 divided by 4. And finally, secant theta, that's the 1 over cosine, if you like, or hypotenuse divided by adjacent, so it's 5 over 3. Okay, now find the values of sine 45, cosine 45, and the tangent 45. sketch the right triangle with angle 45 degree here. Well, if it's 45, what is the remaining angle? That's also 45, right? So what we see is, this is isosceles right triangle, so two sides are equal, right? Well, we don't know what they are. We can denote it like x if you want, it's okay, but or we can simply give any number here. So let's give like 1. Then this is also 1. Then what is this hypotenuse? It's 1 square plus 1 square in square root, right? By Pythagorean theorem. So this is square root of 2. Alright, then what is the sine of 45 degree? It's 1 divided by square root of 2. What is the cosine 45 degree? That's also 1 over square root of 2, right? Adjacent 1 divided by hypotenuse. And you can rationalize the denominator and you'll get like square root of 2 divided by 2. Here also square root of 2 divided by 2. Okay, and then finally the tangent 45 degree. It's the opposite divided by the adjacent, so it's 1 over 1. It's 1. And this 1 is not important, as I said. I mean, you can denote it by x, you would get x there, and then hypotenuse would be like square root of 2x, and the x's will cancel when you do these things. So the values of these trigonometric functions are well defined. They don't depend on x. Alright. Now, let's calculate sine 60 degree, cosine 60 degree, sine 30 degree, cosine 30 degree. Using equilateral. Equilateral triangle means it's a triangle where all sides are equal. But wait a second, I mean, I need a right triangle, right? So yes, I mean, if you drop the height for the equilateral triangle, it's going to be, you will get, so this is our equilateral triangle, so 60 degree here, 30 degree. So in this occasion, okay, so we denote this by 1, but this is also 1. Because of equilateral, this is 2 here, it's 2 here. And then from the Pythagorean theorem, you can find out that this height should be square root of 3, right? Because square root of 3 squared plus 1 squared, that's equal to 2 squared, right? So for this to work, you need square root of 3 here. But once you have it, then the remaining part is easy. So sine 60 degrees. So here 60 is opposite, which is square root of 3 divided by hypotenuse is 2, right? And then cosine 60 degree, it's the adjacent, which is 1, divided by the hypotenuse, by the hypotenuse, which is 2. Okay. And then what is sine of 30 degree? Sine of 30 degree is, so here's my 30. So opposite is 1, hypotenuse is 2. And then cosine of 30 degree, so it's adjacent, which is root 3 divided by hypotenuse, which is 2. Okay. So basically, these are somehow some of the special angles and the values for sine, cosine, and tangent. So why we are not giving the other 3 trigonometric functions? Because like cosecant, it's 1 over sine. The secant, it's 1 over cosine. The cotangent, which is 1 over tangent, right? So once you know the values for these, sine, cosine, and tangent, you can know the values for others. In fact, you don't even need tangent, right? Because what is tangent? Well, the tangent, so tangent is sine divided by cosine, right? So if you know sine and cosine, in fact, you can also find out tangent. So essentially, you need to know sine and cosine. Even more, I mean, in fact, you can only know sine. How can you derive cosine from sine? We'll come to that. But anyway, so sine 30 degree is 1 over 2, sine 45 degree is square root of 2 over 3, square root of 2 over 2, sine 60 degree is radical 3 divided by 2, and then cosine 30 degree square root of 3 over 2, and so on and so forth. So you see, I mean, this cosine 30 and sine 60, they are the same. And then the sine 30 and cosine 60, they are the same, right? They are the same. And sine 45, cosine 45, they are the same. So, so now you can sort of see the pattern, right? Basically, if they add up to 9, right? What we call it complementary, right? Complementary angles. Then their values are the same. So that's what we do now here. So cofunctions of complementary angles, okay. So you see, if this is your sort of x, this is your y, or whatever, theta, if you add them up, you get 90. So which means this 90 minus theta and theta, they are complementary angles. So in this case, sine of or cosine of theta is equal to sine of 90 minus theta. The same applies for tangent, cotangent, secant, cosecant, cosine, sine, and so forth. Okay? Okay. Some of the very important trigonometric identities. Yeah, I already mentioned this thing. So sine of theta, it's 1 over cosecant, or cosecant is 1 over sine. Cosine is 1 over secant, secant is 1 over cosine, tangent is 1 over cotangent, or cotangent is 1 over. So as I said, I mean, using these identities, you can sort of find the values of other trigonometric functions if you know, for example, for sine, right? If you know for sine, you know the cosecant. If you know cosine, you know secant, and so forth. And another one, again, I also mentioned this. So tangent, it's sine over cosine. Why is that, right? I mean, from trigonal, okay, we can drive it from triangle. So let's call this A, let's call B, this is C. So what is tangent? From the formula of this theta, let's say, it's A over B, right? What is sine of theta? It's A over C. What is cosine of theta? That's B over C, right? Now, what happens if you divide sine theta by cosine theta here? So you get, what do you get? You get A over C multiplied by C over B. So you see the C's cancel, you get A over B. That's exactly what we have in here, right? So that's a tangent. And the cotangent is cosine over sine, because cotangent is the inverse of the tangent, right? Okay. And here, sine square plus cosine square is 1. So this is, okay, yeah, this follows from the Pythagorean identities and the remaining parts also. Or you can also see it from unit circle, right? You remember, this is your y coordinate, this is your x coordinate. So sum of the x and y squares is equal to 1 because it's a unit circle. That's the form of a circle, right? Okay, so once you have this identity, you can derive the others. So take it as an exercise. Using this identity, how do you find out 1 plus tangent square theta is secant square theta? How come 1 plus cotangent square theta is cosecant square theta? Simply using sine square plus cosine square equal to 1. Okay? So you should try. That's a good exercise. Easy, not hard, not hard. All right. Some examples. Let theta be acute angle. You remember, acute angle means less than 90, so between 0 and 90. Yeah. And such that sine theta is 0.6. Find the values for cosine theta and tangent theta. Right. Well, it says, okay, first let's find it says using the identities, right? So I could sketch the triangle. I could sketch the triangle and then do it, but since I'm asked to do it with identities, I will do it. But what is the identity between cosine and sine? It's this sine square plus cosine square is equal to 1, right? Okay, what is my sine square? My sine square is 0.6 square plus cosine square theta is equal to 1. So which means cosine square theta is 1 minus, what is 0.6 square? It's 0.36 36. 1 minus 0, 36 is 0, 64. Now if you take the square root, which implies cosine theta is square root of 0.64, which is 0.8. Well, in fact, this is plus minus 0.8, but because I'm on the first quadrant, my x and y coordinates from circle method, remember, they are both positive. So in particular, x is positive, so cosine must be positive, right? Okay. How about tangent? Well, tangent theta is nothing but sine theta divided by cosine theta. So sine theta is 0.6, cosine is 0.8, so this is 6.4, so 3 divided by 4, right? Okay. Let theta be an acute angle such that tangent theta is 3. Find values for cotangent and secant using trigonometric identities again, right? All right. Well, cotangent is easy, right? Cotangent of theta is nothing but 1 over the tangent theta, so which is 1 over 3. All right. How about secant? Well, what we know is 1 plus tangent square is secant square, right? So secant square theta is equal to 1 plus tangent square, so tangent is 3, so it's 3 squared, which is 9 plus 1, 10. So secant theta is square root of 10. Again, it must be plus minus, but in the first quadrant it's positive, so yeah, positive plus square root of 10. All right. Another example. So this is like an application. So it's about finding this height, right? You have some tall object like this. So this is Washington Monument, and you want to find out its height. But how do you do it? All right. So I have this angle 78.3 degrees. I can measure this, which is 115 feet, the distance between the person and this monument. Now I need to find the y. So what we see is a right triangle here, right? So we know this 78.3, here I have 15. So here is y. Now, which trigonometric function connects these three, y, 115, and this angle? Well, we have cotangent, we have tangent, right? Okay, so let's use the tangent. So tangent 78.3 degree, that must be the opposite is y, divided by adjacent 115. So this height, y is equal to 115 times tangent 78.3. But be careful, this is degree, right? So if you're using calculator, you need to be careful. It should be using the degrees here, or you need to convert it to the radian and then do it. So anyway, so this is approximately 115 times, so tangent 78.3, it's roughly 4.828. So this is roughly 555 feet. So that's the sort of roughly the height of Washington Monument according to the given information. So let's do another application. So find the length C of the skateboard ramp shown in this figure. Right. So again, we see a triangle here, right? So this is right triangle here. Okay, so which trigonometric function connects the three? So I have this opposite side, I have hypotenuse, and I have 18.4. Well, I can think of two of them. So one is the sine, another one is cosecant. So let's use this sine. So sine of 18.4 degree, it is 4 divided by c. I need c, right? So c is 4 divided by sine of 18.4. So again, we need to use the calculator to estimate the sine, so which is 0.31516, which is once you divide roughly 12.7, okay, whatever the units. So skateboard ramp, so nothing is shown, so I don't know. It could be meters, it could be feet, and so forth. Okay.